Okay, this is the M1 paper from January 2023. It's question number 3, and this is both a vectors question and a kinematics question at the same time. Let's have a look at it and see what we've got. It says particle P is moving with a constant acceleration minus 4i plus j. At time t equals 0, the velocity is 14i minus 5j, so that's going to be my u. And it then says, can we find the speed at 2 seconds? So yeah, absolutely we can. Let's write down our suvat. Excuse me, we have that u is equal to 14i minus 5j. V is what I'm trying to find, or rather speed. Speed will be the magnitude of that velocity. They've told me that the acceleration is minus 4i plus j, and they've told me that t is equal to 2. So if I've got v, u, a, and t, and I'm trying to work out v, I can just simply use the equation v equals u plus at. So v is equal to 14i minus 5j plus 2 lots of minus 4i plus j. V then works out to be 6i minus 3j. And just be careful, they've asked us for the speed. So speed is equal to the magnitude of the velocity, which is simply the square root of 6 squared plus 3 squared. And that works out to be equal to 3 root 5. Let's just check. Do they say, well, they didn't say the exact value, but I'd leave it as that. Anyway, when we're going on, part B, the size of the angle between I and the direction of motion of P at 2 seconds. So what that means is if my velocity is 6i minus 3j, let's just draw out what that would look like. 6i, but then minus 3j means that my vector is going to look something like that. That's 6i minus 3j, and what they want is the angle that it makes with I, and obviously I would just be the vector there. So the angle that it makes with I then is this angle theta here. So if I want to work out that angle, we can simply say, using SOHCAHTOA, tan theta is equal to opposite over adjacent. So tan theta is equal to 1/2, which means theta works out to be equal to tan to the minus 1/2, which is 27 degrees. Again, it doesn't say anything about accuracy, so I'll leave it as 27 degrees there when we're doing part B. And then part C, says, at time t equals t, it's now moving with or rather in the direction 2i minus 3j. Can we work out what the value of t is? So if we've got that situation, yeah, absolutely, we can go ahead and do that. We know for part C then, it's going to be suvat again, isn't it? So we've got S, U, V, A, and T. The U hasn't changed, it's 14i minus 5j. The acceleration hasn't changed, it's, excuse me, minus 4i plus j. V is going to be something new, and it's going to be at time t equal to capital T there. So again, if I want to work out what V is, let's just do V equals U plus AT. I'm going to do it here simply because it's easier to see on the screen there. So my V is going to work out to be equal to, just like it was last time, 14i minus 5j, but this time plus minus 4i plus j times t rather than an actual value. Okay, so what I can do with that is I can then get that in terms of t, just for i's and for j's, and I'll make it clearly what I mean by that. I've got 14i there, and I've got minus 4ti with those bits combined. So for the I, I've got 14 minus 4ti, and for the j's, similarly, I'll have t minus 5j. Now, how does that help me? Well, I know that it's in the direction of 2i minus 3j. So it's parallel to 2i minus 3j. So v equals 14 minus 4ti plus t minus 5j is parallel to 2i minus 3j. So the simplest way of doing it then is to say that this divided by this is going to be the same as this divided by this. Nothing more complicated than that when we're looking at two parallel vectors. So I can say t minus 5 over 14 minus 4t, the j value divided by the j component divided by the I component, is the same as minus 3 over 2. And now that's a simple thing to be able to solve. We'll do it. It works out to be 2t minus 10 on that side. And it works out to be, what's that, minus 42 plus 12t on this side. And then just rearrange it. We get that 10t works out to be equal to 10t works out to be equal to 32, which means t works out to be equal to 3.2, and that's seconds. Everything's been measured in seconds, so 3.2 seconds. Yep, that's the way that you do that question. Not too bad, relatively straightforward. Hopefully that all makes sense to you.